morning, everyone, and digital welcome to this event organized by the European Alliance to Save Energy, by the European Association for Building Automation and Controls, and Lighting Europe. I hope you are all well and also curious to hear about smart technologies and their link to the Energy Performance of Buildings Directive. And you're also ready to participate actively in this debate today. My name is Brook, and I work for Industry Affairs at Smart Infrastructure at Siemens. I'm also the Vice Chair of the European Alliance to Save Energy. I'll be your host for today, and the event is titled the EPBD Revision: How to Make the Building Stock Decarbonized, Energy Efficient, and Healthy through Smartness. We will start with this virtual conference with a series of opening statements from the speakers, and then we'll move to the panel discussion and the Q&A session, moderated by me, that will also include questions from the audience. To put your questions to the panelists, just use the question box on your screen, and we'll take your questions and answers and answer them during the panel discussion session. Few other pieces of practical information for you. The webinar is being recorded and will be made available together with the slides after the event. About the Q&A, I have already informed you, and in addition to this, to increase the interaction between the panelists and the audience, we would have polls which will be launched during the presentations. So please, when you write your question in the question box, it would be nice to mention also to whom you address the question. If it's a question that you'd like to ask all the panelists, then of course you can put all if you want. So together with me today, we have an esteemed panel of speakers from the European Parliament, the building industry, and a well-known European think tank. Namely, we have MEP Pernille Weiss, member of the European Parliament, Nils Meinert, Managing Director from Johnson Controls, Ourania Georgoutsakou from Lighting Europe, and Jonathan Volt from Building Performance Institute Europe. Welcome to all of you, and thanks for joining us today. So to warm up, we'll start with the first poll. On this slide, please, can we have the slide with the QR code? You see the QR code. Please scan it to access the question and to provide your answer. And the question is, are smart technologies in buildings essential for Europe's decarbonization? Are we also going to see the poll with the different options on the screen? Could we also put the link in the chat box for the participants, please?
The link is already in the chat box.
Okay, good. Thank you. So are we going to see the poll then? Yeah, very good. So that's the statement. Smart technologies in buildings are essential for Europe's decarbonization. And you, dear participants, have the following options to answer. Strongly agree, agree, somewhat agree, somewhat disagree, disagree, or strongly disagree. So please go ahead. Oh, we have already 61 votes. We have how many attendees? 122. So we could wait for a bit longer. Good. So what we see here, it's a very, very encouraging result for us, really, because most of the participants strongly agree that smart technologies in buildings are essential for Europe's decarbonization. And I do see a few people, 5 right now, that somewhat disagree. I'm very curious for these people to challenge the discussion and to participate in the debate, of course, for everyone else. But this is extremely important to also understand why certain people disagree with it. So I'd like to give you some figures. Published recently by the World Economic Forum, which underline the potential of using smart technologies in buildings. Basic automated building controls can save 10 to 15% of energy. More advanced functionality, such as demand-controlled ventilation, can save an additional 5 to 10% in energy. Integrating building systems can bring energy savings of 8 to 18% over basic control of individual systems. Automated fault detection and diagnostics can save an average of 9% in energy use. And in addition, grid interactive efficient buildings can reduce energy costs by up to 20% through active demand management. Despite this positive impact, most of the potential of digitalization is still unexploited in the building sector. And the upcoming revision of the Energy Performance of Buildings Directive, or the EPBD, creates a unique opportunity to leverage a broad range of smart technologies to make our buildings energy efficient, future-proof, and more comfortable for its users. All businesses represented by the 3 industry associations and organizers of this event believe that reducing energy demand and increasing energy efficiency in buildings is a prerequisite for achieving the climate objectives of the European Union. Furthermore, we are convinced that highly energy efficient and smart buildings are the first and indispensable step to accelerate the deployment of renewable energy sources and enhance overall system efficiency, foster sector integration of buildings with industry, transport, and energy sector, stimulate a sustainable economic recovery, and boost local employment. In our opinion, stronger policy measures for highly energy efficient and smart buildings are necessary to meet the revised climate targets of the European Union and to fully decarbonize the building stock by 2050. And this is the right point of time to hear from MEP Pernille Weiss, who will share her message to us. Unfortunately, MEP Weiss could not make it live with us today due to an extraordinary parliamentary call at a short notice. So she was so kind to pre-record a message specifically for this event and to us. So if we're ready, let's hear from her.
Hello, dear European Alliance to Save Energy and Lightning Europe. Congratulations to your event that unfortunately I cannot be a part of. But with this little message to you, I would like to underline that I hope it will be a success, because we really need to promote a sustainable recovery by speeding up energy efficiency and also the inclusive digital transition of the EU building stock, because the energy prices right now are increasing, and we know that energy that we do not have to buy because we are clever and better in doing energy efficiency, we don't have to pay for. Also, by doing more energy efficiency of the building stock, we improve the skills of European citizens and workers to be better equipped to the green transition of a lot of industries, not only related to the building sector. So I very much encourage you for a good talk, for a lot of ripple effects from today's event, and I look forward to continue my conversation and cooperation with all of you stakeholders in the near future. Thank you so much.
Thank you. Thank you very much for this message, MEP Weiss. Indirectly, and if you watch the recording of this event, we are very, very grateful that you find the time and that you pre-recorded this for us, so we really can hear your message. And just a couple of words about MEP Pernille Weiss. She is a Danish politician from the Conservative People's Party of Denmark, elected as a member of the European People's Party in the European Parliament in 2019. She holds a seat in the Industry, Research and Energy Committee, ITRE. So without further ado, let's move to our next speaker, Nils Meinert from Johnson Controls, who will talk about cost-effective, active energy efficiency solutions in renovating European buildings. Nils Meinert from Johnson Controls has been in the building industry for 30 years. He is a member of the board of eu.bac, the European Association of Building Automation and Controls, and supports eu.bac in driving directives for energy efficiency and automation of buildings, as well as standardization for building automation. So Nils, I can see you're ready. Over to you.
Thanks, Bonnie, for that. And I hope you all can see my screen, my presentation now. So
yes, we can. Yeah.
Perfect. So therefore, I like to introduce myself, of course, a little bit. I'm with the building automation industry now for more than 30 years at Jones Controls and a couple of other companies. I was driving the building automation business for years. And now I'm also a member of the eu.bac board and one of the vice presidents of the eu.bac. So it's really my pleasure here to present eu.bac and eu.bac's position regarding EPBD, so the European Energy Performance Directive. And I hope I can add to that some examples that you can understand the position, and therefore I can explain that also a little bit. I will switch on my camera as well so you can see me here. So therefore, let's start with introducing eu.bac a little bit. eu.bac is, and you see here a lot of companies are members of eu.bac, companies from the building automation industry, but also from the buildings, technical equipment industry. We have here as members of the eu.bac. So at least driving from the industry solutions that allows a building to be energy efficient and at least with that sustainable. Then you will see that a little bit later. Most of the time as a building is in operation, is it necessary to save the energy not only during the erection or the tear down, but during the operation of the building. So starting with that, what building automation controls means is, of course, there are a lot of products. You can see some ideas of that, what building automation controls is able to control in a building. At least all these products, let's say these are valves, actuators, these are bigger units for heating, for ventilation. All these units are controls and also controlled and also managed by a building automation control system. So from the simplest sensor or activator, so let's say a thermostatic valve as a very simple actuator we have, not really communicating to the communicating valve, then up to the bigger management systems. So building automation controls with that is a kind of brain of the building, where all the different operational processes are controlled, monitored, and also can manually influenced for that. But it's not only somewhere a brain, it's consists of a lot of intelligent devices, so-called intelligent nodes, where sampling all the data, having also some intelligent insight that a lot of things are are processed and operated in these nodes. And on top of that, and that's something what is more and more important for having a smart or digital buildings, is having really on top on that a system can do real-time analytics, reporting services. So at least that you can create with that a digital twin of the building using for operation of the building. What does that mean for saving energy, or what does that affects for all the energy savings initiatives? So looking at a study, we quite often using also for discussing what is the impact of building automation and control systems. Then you can see on the left-hand side on this slide that in the different types of buildings, you can save quite a lot of energy by controlling and managing energy consumption via building automation control systems. You can say the more different the usage of a building is, the more energy you can save by reducing energy consumption in these times. The building or an area of a building or a room is not in operation, for example. And that looking into that and using building automation controls, and with that some intelligent devices for reducing the energy consumption, you can result in these quite big numbers what cost and energy efficiency and cost reduction means. So for sure you have to invest something for that, for building automation and controls. And also what came up with this study is that in average, depending on the kind of building and usage, you have to invest less than 30 euro per square meter of building space for building automation and controls equipment. So with that, and saying that in average we would save 14% of the total building primary energy, so that would mean you have a return on invest of about 3 years. What is not really a long time for a return on investment if you think about that a building from the erection to the first renovation usually is just a time of 15 to 20 years usually. To making that a little bit more practical, I like to show you, and that's then from Johnson Controls, an example where we have such a building where a lot of different subsystems, intelligent nodes are in, for a couple of different disciplines, a couple of different units we have in. So we have the usual air handling units, room control, lighting control, heat pumps are in here in that buildings. You see also that there is solar energy using, so photovoltaic energy with the meters and the storage in the building that is also managed and coordinated by building automation and control system. And we have a lot of smart lights in, also managed then via a smartphone app. The user of the building can use for that, switching on and dimming the light. And on the other hand, that's also together with blinds and to coordinate also the light between the external light is coming in. All that is also connected to access control, CCTV, to make sure that you can operate the building, but also that people are working in that building can access, and with that also impacting their room, switching on light and bringing it into a comfort mode. Quite a lot of local building automation and control systems for managing that, together with a building management station, in that case Metasys as a John Controls product, with using all the weather data and doing the energy management, but also then using a cloud-based application, so John Controls Enterprise Management, to sample all the data, to do the analytics, and with that make sure that the building is operating well. And with that you can see if something is going wrong, if lights are not switched off, or if a room is in operation, if it's not occupied, so being in manual operation, for example, only to show up some examples what building automation and controls can do in this such a building, what is quite a big one for sure, but more or less the same functionality you can also implement with using smart components, using components are able to connect to all other building equipment and to building automation and control system, also in smaller buildings. Looking on that a little bit more on from a higher level, then and what is going on with the building, and what is that related to the building and control system, to have sustainable and smart buildings, then you all know, start with number one here, that we want to have clean air in a building. As more as a pandemic situation is coming up with that, the air should be in a good condition. That also impacted the so-called well-being or motivation of people are working in a building. Depending on that, what is demanding for that area where the people are working. Even it's a storage space or the office space, or is that a conference room, whatever. So therefore, it's important having right temperature, humidity, the light, the lighting coordinated with blinds, for example. So all this stuff is coming together here, and it's important for the productivity and of people are working in. And in the next step, then all these environmental, social, governance, compliance issues came up. So not only that we are erecting a building and equipping a building with some devices, but also that devices we are using are conform to all these environmental requirements we have, and also make sure that over time we also take care of the usage of resources we have as demanded from the building and the users here. So what leads to the at least reduction, or in best case of zero carbon, so reducing of the CO2 output here or usage here, and that's quite together with energy efficiency. So by reducing the energy, you also going to reduce the CO2 footprint on that. And at the same time, you want to have quite a high resilience against that something is changing or running away. So you have to make sure that over the time of buildings in operation, all these different requirements are really in the right shape and as expected, and so that you're not running away from, let's say, a zero carbon building by using a lot more energy as you expected because of a different operation of the building. So with that and having the energy efficiency, for sure, you can also reduce the energy supply cost. You have seen an example, there was a photovoltaic.
Excuse me, Nils, it would be great if you can sort of spend another couple of minutes only.
Okay,
just heads up for you. Thank you.
Okay, thanks. So what also reduce the cost per square meter, what means the total cost of the building is reducing over the operation time, what is more than 90% of the time a building exists. So therefore, you see it's quite important that the operation of the building is in a good shape. And so therefore, it's a position of the eu.bac really to implementing the existing EPBD, what is described the mandatory implementation of building automation control systems. So having smart buildings with energy output of more than 290 kilowatt of a building. So we prepared some guidelines and also verification list for that a building owner, also a consultant, and also national policymakers can use that as a guidance how to manage that. And with that, it's quite clear that digitalization is part of that, and is part of that what the building automation controls is doing all the time. So therefore, that's my last slide then, Bonnie. The position of the eu.bac is that we have to implement in all the member states minimum energy performance standard, what is at least in the EPBD, in the revised EPBD included. So and with that, smartness of a building is key to really realizing the energy performance of a building. What also means that all the components have to be built in, should be fulfill a certain requirement regarding smart readiness. So being prepared to connect to each other and connect to building and automation control systems. And with that, and that's the third one, eu.bac is promoting here that not only for non-residential buildings as it is now, we have to implement some energy performance standards, but also for residential buildings, and with that also for smaller buildings with an effective rated output of more than 70 kilowatt, what is much smaller than in the actual revision of the EPBD direction, and the same level should also then be effective for non-residential buildings. So that should give quite an input for a good discussion, and so I'm curious about and happy to answer your questions regarding that. Thank you.
Thank you so much, Nils. Thank you for this very detailed information on building automation and controls. and also the policy asks of eu.bac for the upcoming EPBD. So now it's time for our next poll, and this time you won't have that much time, dear participants. So please, now you had your rehearsal with the first poll, go to the next question, and you have 1 minute to cast your votes. And the question is, which measure in the revision of the EPBD is key to unlocking smart capabilities in the European building stock? And the options for answers you have are: first, inclusion of digitalization requirements in the minimum energy performance standards. Second, BACS requirements in the residential sector. BACS stands for Building Automation and Control Systems. Third, mandatory smart readiness indicator requirements for certain buildings. You also have fourth option for others, that you can use the chat box or the questions box to put if you have any other ideas how to answer this question about the measures. So please start, and you have 1 minute. Okay, so we are at 79 as before. Oh wow, that time we passed the 80. Very good. I think that's the time gone now for the poll, and the results you can see on the screen. The winner is the inclusion of digital requirements in the minimum energy performance standards, followed by the mandatory SRI requirements for certain buildings. And then we have many votes also for the BACS requirements in the residential sector. So that's very good. I cannot see the comments on the other specific ones, not in the question and not in the chat, but it doesn't matter. Please, if you want, you can type it down for the rest of us to share your idea. So now let's move on to our next speaker, Ourania Georgoutsakou from Lighting Europe. She's the Secretary General of Lighting Europe, the voice of the lighting industry in Brussels. Ourania has over 15 years experience in advocating for membership organizations. Thank you very much, Ourania, and please take the floor.
Thank you very much. Good morning from my side also, everybody. I've just launched my slides on the screen, so I hope everybody can see them. A warm welcome also from my side. It's
not yet. We can. Yeah.
Wonderful. Thank you, Bonnie. So also a warm welcome from my side, and thank you to everyone who's joined today for this very interesting conversation. I'm reassured by the results of the poll we just had now about the need for digitalization, and I'm really intrigued about the not so sure people on the first answer, on the first question and answer session. I really look forward to having an exchange around that. Briefly, the thoughts from Lighting Europe about how we think we can contribute to decarbonizing and improving the energy efficiency of Europe's building stock through smartness. First of all, a brief introduction to who I represent. Lighting Europe is a trade association representing lighting manufacturers from across Europe. That means the companies that manufacture light bulbs, that you know, luminaires, the controls that go with it as well. We represent 30 members, so a mix of companies and national associations representing companies, altogether about 1,000 companies from across the wider Europe. And we have a vision in this trade association, which was developed back in 2016, and it actually reflects the mission of Lighting Europe as a trade association. Our members decided and put forward a roadmap in 2016 about how to deliver the value of lighting to people and the planet by 2025. And basically what that consists of is building on the potential that electronics technology, LED lighting technology, can offer, deliver energy savings, sustainability and durability, and move on to the rollout of intelligent lighting systems that can deliver on human-centric lighting. And it's those two elements that I will focus on my presentation this morning. I think we can all agree that this is not only a strange time in Europe, but also for the world, not just because of the pandemic, but it's really a time when we've decided to translate, at least in the EU, our values into policy. We have a very firm commitment around greening our policies, our industries, and our actions. The EU Green Deal puts that really in writing and makes a commitment in law and in practice for all of us. The commitment to a renovation wave is also an impressive piece of, I think, policy that we've not seen in a while. It's attached, it has money attached to it. And we're really talking about renovating about 35 million inefficient buildings by 2030. And if you think about it, today, in our pockets, you and I, we have more computing power than what put a man on the moon back in the 60s. So the electronics, the technology is here today to make everything digital and improve our life. So quite frankly, why wouldn't we use that benefit also as part of this renovation wave, this once really in a generation opportunity of driving renovation forward for energy savings for the planet to also contribute to that objective? And I'd like to talk to you a bit about how lighting can contribute in that context. Already at an individual product level, LED technology, lighting technology, allows us to deliver significant energy savings. When you compare today's LED light bulb to the incandescent lamps that we used to have 15, 20 years ago, we already delivered up to 90% energy savings between those two products. With the new legislation that starts to apply already in September this year, we are delivering 7 million tons of CO2 equivalent a year by 2030, and that's already on top of the 12 million tons that were delivered by the legislation introduced in 2009 and in 2012. So today, just individual light sources can contribute significantly to energy savings. And there's a big transition towards those light sources. Firstly, technology driven by the industry. Most of my members are all LED based. I think there are about 90% of the companies I represent have only LED technology in their catalogs, and that number continues to increase. Now, imagine taking that and connecting those individual light sources into a system. So adding sensors, adding controls, that really allows us to even further optimize the energy savings that we can deliver. By the European Commission's own estimates, they expect 20 to 29 terawatt-hour per year by 2030, or 48 to 56 terawatt-hour per year in 2050. So just putting that all together, that technology together into a lighting system can really deliver even more energy savings. And it can do more because the controls and the sensors will not only manage how the lighting operates, it would also deliver additional functionalities. And I think we should not forget that today in our conversation when we talk about digitalization delivering on energy efficiency. We should remember that digitalization technology can do more. We can go beyond energy efficiency. And if you just take a moment to think about it, in the end, you and I, despite millions of years of evolution, we are all still animals. And we are governed by our body clocks, what's called as a circadian rhythm. And that body clock is synchronized to phases of daylight and of darkness. Still today, even though we live 90% of our time indoors. And that means that lighting and our exposure, our access to light, impacts not only how we see and how we navigate the environment around us, so operating when there's darkness outside, feeling comfortable, feeling safe. It also impacts our body, so how alert we feel, how awake our brain is and functioning it is, how quickly we can think, how well we can fall asleep at night and how easily we can get out of bed in the morning. And it also impacts our mood. Are you in a good mood, bad mood? Do you feel energized or relaxed? And that means that by using the right lighting at the right place and at the right time per person, we can really deliver even more benefits to people. That's about having lighting systems that allow for dimmable light, so allowing you to either boost or dim the intensity of the light. Lighting that is tunable, meaning that you can play with this lighting system across the different light spectrum, the color of the light, and all of that allows you to adapt the lighting to who you are, where you are, and what you're doing. Because indoor lighting is deliberate. It's not, let's stick a light bulb in the wall or in the ceiling and off we go. Good lighting design and good lighting systems are all about a set of deliberate choices, decisions based on how people will function in a space, what they will do, how they will do it. Let me show you in practice. This is an example of an office in Spain. Like I said, the technology is already there. It already exists. It's already installed. It's being used. Just to give you an idea of a few things that happen in this space, you have lighting systems that allow for this dynamic, tunable light, which changes temperature throughout the day in order to mimic daylight. So the light in your office is not static. It's not always the same intensity, and it's not always the same bright color, just like the sun outdoors. In the morning, the light is regulated to a cool light at around 5,500 Kelvin. That makes you feel energized and awake. You need cool, bright light to wake up your brain and your body. And later in the afternoon, when it's time to wrap up, relax, and move towards the end of the day, it goes down to a more warmer color temperature. You will see that in the meeting room, we have a different color because you're not supposed to sit there and actually type at your computer. You're supposed to sit there, be able to look at people, maybe look at the screen, but also feel a bit more relaxed and brainstorm. And on individual workspaces, you also see that there are presence sensors. So it allows people, like in the meeting room, it allows the system to know, is there someone sitting there? Do we need to switch it on? Do we need to dim it down? So optimize the use of the lighting. And it also allows you to make a personal adjustment. So I know a lot of people have often told me, but Ourania, I sort of like to play with my own light. I don't need anyone to decide. That's fair. And that is still possible within automation, within digitalization. So technology already out there, installed in our ceilings already today, delivering energy savings and better quality of life for people. And that has been proven, this better quality of life for people, because the studies done in offices, in homes, in places where we have installed this better lighting, these lighting systems, shows that people perform better at work, so you're more concentrated, there's less accidents, you can do your tasks better, our children do better at school as well. And frankly, when you think about it, in an office environment, in a building, why wouldn't you do this? Not only does it deliver energy savings, but the most important thing in the end, in the building, is the people and how we feel and how we operate. So with automation, with digitalization of our lighting systems, we can also improve how we navigate indoor environments and how we feel and perform in them. So to wrap up, in Lighting Europe, we have made the following recommendations about what we want to see in the Energy Performance of Buildings Directive and in the renovation wave. And I'd like to run you through these, please, briefly. First of all is we need requirements on smartness of buildings. You have to mandate the use of automated lighting control systems in non-residential buildings at least. But the legislation has to make a clear statement to that effect. We want to see a harmonized application of the Smart Readiness Indicator across Europe. It's a tool, it's a good tool, it remains voluntary. We have to make sure that everybody's using it and that what we get is a harmonized approach to how it's being used. We should have requirements about inspecting lighting systems because we can all make a great design, but it's important to make sure that that design is installed and that design is then maintained regularly. So the legislation at European national level should mandate those inspections. We'd like to see minimum requirements for indoor environmental quality, also for lighting, and those requirements exist in lighting standards. That's not a novelty if you think about it. Other energy performance rules, for example, at light source level, so the individual product, include performance requirements that are not only about the energy savings, but also about the quality of the product. So it is fair in a piece of legislation, of European legislation, looking at energy efficiency, to also think about the quality of the environment. We should definitely make sure that the financing continues to come. We have a big financial wave coming out in response to COVID as part of this EU Green Deal and the renovation wave. It should mandate and support the renovation of lighting to transition to these LED-based lighting systems. And the conditions are there in terms, set some conditions in terms of smartness and also quality of light, like what's in the standards already today. And then, of course, let's follow up with member states to make sure that their long-term renovation strategies are being forced so that we can reach the targets we have. And with that, I thank you for your attention and the opportunity to briefly introduce you to the amazing world of lighting today. Thank you, Bonnie. Thank you all.
Thank you so much, Ourania. Thank you. That was a very good overview, but of course, with a lot of detail in it, that lighting systems, smart lighting systems, not only reduce energy consumption, but they also are so important for us human beings. And this is only another one of the multiple benefits that smart technologies could bring. So thank you so much for that. I would just like to remind the audience to start putting your questions in the question box as soon as we actually have the next poll when we finish it. So let's have the next poll, please. And this time the question is: smart technologies in buildings are essential for a better indoor environmental quality. The revision of the EPBD should go beyond energy efficiency and also address indoor environmental quality. So please, everyone, let us know what you think. The 6 answers are already known, it's just a couple of words. So let's see what we can do in a minute. So, and I can see there are a lot of fans of smart lighting systems in the call, as well as smart technologies. I'll take it, and of not only going for energy efficiency, but also addressing the indoor environmental quality. So thank you so much. I think the result is very clear, and I will now invite Jonathan Volt, who is our final speaker today. Jonathan is from Buildings Performance Institute Europe. He is a project manager there, and in the last couple of years he's been very focused on working on building renovation passports and digital building logbooks. So Jonathan, welcome, and over to you.
All right, thank you, Bonnie, and thank you for having me. I'll just share my screen. I'm sorry, I have a slight cold, but I apologize for that. And for your sake, I'm happy this is a webinar and not an actual meeting. But I'm happy to be the last one to present here, because I will repeat a couple of things, and then, as Bonnie said, I'm a building policy expert rather than a smart building expert. So I hope to bring a couple new perspectives to this discussion. But yeah, my name is Jonathan. I work at the Buildings Performance Institute Europe. We're a non-profit think tank and based in Brussels and Berlin. And yeah, all right. So this was basically a repeat of what Ourania just said. And with this, I just want to say that during the 2 last years, maybe we have seen that that climate and building policies have really started to picking up speed. We have the new climate target of 55% reduction by 2030, and of course in the renovation wave they stated that they want to increase the renovation rate from 1% to 2% within the next 10 years. And this, of course, requires a lot from in terms of actual policies, actual regulations, and so on, but also from the industry. And let me go through here. So, well, before I do that, basically what I will do in this presentation is to highlight what are the anchor points in the renovation wave that we see. I mean, we only have the strategy, but what are the terms and concepts and measures that we maybe can use to leverage the smartness? Because in the end, as was concluded in the two previous presentations, we really need smartness in buildings and in districts to really meet these targets by 2030 and to be fully decarbonized by 2050. But of course, renovation wave is not happening in a vacuum. It is happening together with a bunch of other big global changes that influences both how we use buildings, how we use, how we heat and consume energy in our buildings and so on. And I would just go through a couple here. Let's see if I can. All right. I will go through this quite quickly because you all know this. Nils said that he was talking about building automation and control system. Technical building system is, of course, but we also see that there are a huge increase in number of components in our buildings and in our homes that actually can communicate with us and with the energy system. I mean, on my phone, I can control my washing machine. And I mean, I think that opened up to be a lot of opportunity for new business models and so on. We have an increase of electrification of the energy system. Electric vehicles and heat pumps are increasing very fast, and of course, two drivers of this electrification. And this, of course, opens up new challenges, but also opportunities for buildings and for the energy system, as does the increase of especially solar power and wind. That brings some volatility to the energy system. And this, I will come to this in a couple slides, but this requires our buildings and our energy system to become more flexible and more adaptive. There is an increase of servitization. More and more things that we used to buy as products are becoming services, and this is something that probably will increase. And technologies such as building automation and control system can, of course, enable this. And of course, data, it relates to the digitalization, but everything we do is basically recorded somewhere. And this is maybe, worrying from an energy, from a privacy perspective, but from a bigger perspective on how we can reduce energy and improve how we use energy in our homes is also a great opportunity if we can really use this data and make sense of it. And of course, going back to where I started, climate change, but also the civil society, the climate movement are really requesting a change. And with that, I just want to say that it's we don't really have the time anymore to take these incremental steps. We need big changes now, and I think the renovation wave was really an ambitious. This was something the Commission did to try to do this, to try to really increase the renovation activity of the built environment and to reduce the climate impact of heating and so on. And now today we have an ongoing gas crisis, and we have high electricity prices in most parts of Europe. And there's also we also need to reduce our energy need because of energy security reasons, to make sure we don't end up in these positions in the future. But the renovation wave will lead to that they will open up a number of directives. We have seen proposals for most of them this summer. The Energy Performance of Buildings Directive will come in this December if everything goes as planned. But what I really like when I read the renovation wave is that they don't just focus on this objective of increasing the renovation wave from 1% to 2%. They take a much broader perspective where they really try to bring in buildings role in the wider energy system, the social perspective of buildings, to really try to improve a wide range of things at once. Of course, upgrading the construction sector to make them able to carry out the renovation wave and so on. And I think if I go back to the buildings in the energy system, this is a graph we did now 5 years ago, where when people still talk about buildings, they saw buildings as a dead object, as an object that people just lived in, they worked in, and this building then consumed energy. What we said and it's as true today, is that buildings are really in the intersect, or can be in the intersect of renewable energy production, energy storage, and demand response, and then become really what we call micro energy hubs. So not just consuming energy, but producing energy, storing energy, and making sure that we optimize the energy use as well as the indoor environment to follow up what Ourania just said. But we also concluded that to be able to do this, we also need to have a building that is energy efficient in terms of the non-smart components. I mean, it needs to be well insulated, because if you have solar power on the roof and it just goes out the walls, you won't be able really to valorize the many benefits from that. And then we also said that, of course, these micro energy hubs also need to be intelligent, to have some kind of building automation and control system, for example. And here I just made a couple conclusions. I have said this before, so I won't stay here. But going back to the renovation wave, and I think both the other presentation presented a couple what they think we should see in the renovation wave when it comes to smartness and increase the smart readiness of the building stock. Here I won't say these are not my recommendations, but these are just some of the main anchor points that I have seen in the renovation wave that I think can be used to leverage smartness, which is of course then needed to decarbonize the building stock in a meaningful way. And of course, the smart readiness indicator, this has been mentioned, but it's of course the most obvious way to do this. We have the digital building logbooks that I worked a lot on, which is then a digital repository of all building related data. There you could potentially also link there the real-time data of buildings, and by doing that enable new business models and so on. We have the energy performance certificates, which shows the energy performance level of the building, or they intend to show the energy performance level of the building. And this could also be upgraded, or they will do upgradation, or they will upgrade this in terms of quality and reliability and so on, probably. But they could also upgrade them to include, for example, just show if this building is smart. Does this building have demand response capability, for example, or is this building part of a district that might turn into a smart district in the near future? We have the nearly zero energy buildings, which is basically the minimum standard for new buildings. There you could, I think they should be upgraded to become, a net zero or even positive energy buildings. But it can also include smart components. For example, certain buildings should have a building automation control system. All schools and hospitals should have certain lighting system and so on. And related to that, the building renovation passport is this individual building renovation roadmap for existing buildings, setting out which renovation does the building need to carry out, and which order does it need to carry this out in order to become future-proof. And within, I mean, in these recommendations, we of course need to integrate the smart components, and that is a given, because otherwise you won't reach the high energy efficiency level of the buildings. And minimum energy performance standards, what was mentioned by Nils, I think there is for non-residential buildings or larger buildings, you could do what Nils proposed, to include certain requirements that they should have certain level of smartness or control systems. But then there's also, I think, for all minimum energy performance standards, there's a need to also link it with the actual energy use and not just the calculated energy use. And there we also need, we need a better way to understand what building use and how much energy they use and when they use it and so on. Electromobility, this was a bit discussion last time, but to expand this to have more charging points and to enable the infrastructure of what I call micro energy hubs. And then finally, I think, going back to my micro energy hubs slide, I think then we talked about individual buildings a lot, but I think what I see in the renovation wave and I think we need a change of how we see buildings. They're not individual components, but they are part of a district. And if we really will leverage the many benefits there are from smart buildings, we really need to take a district approach. And this is from one of our projects called Sonikia, where they develop a sustainable plus energy neighborhoods and test it in different countries. I expect people to interrupt when the time is running out, because I also want to have time for the discussion, but I have here three opportunities or recommendations that I just want to highlight. The first one I've talked a lot about. We need to integrate buildings into the wider energy system, and we need to view buildings as part of the energy system. And I think part of this is to define what is positive energy neighborhoods, because it's clear that we need to evolve neighborhoods or districts to positive energy. And to do that, we of course need to increase the efficiency level of the buildings that are there, but also increase the smartness level as well as other systems.
Excuse me, Jonathan.
Yeah.
You have 2 more minutes, Max, 2 minutes, please. Yes.
That's more than enough.
Yes.
Thank you, Bonnie.
Thank you.
All right. And then, of course, making sure, I think Neil said it, but new buildings could be required to have active energy management and storage solutions, which could be required in the new, if there will be a new NCEP definition, and support local authorities or require local authorities to really develop plans of how they will develop districts into smart districts or into positive energy districts. And I think the living labs that are quite many now across Europe, and many of them funded by the Horizon Europe. And there I just want to say that I am part of a new project, Open Lab, where we will do exactly this. We will try to develop smart district and positive energy district solutions in 3 countries, in Genk, Pamplona, and Tartu. And we have the kickoff meeting next week, and on the 20th there will be a public launch. You can follow this online if you want to hear what one of these living labs will do. I have mentioned this, but the digital building logbook really needs to enable a cross-sectional use of data. The digital building logbook brings together the data from a number of different databases. It enables interoperability of this data, and in theory then make use of this data for different actors. And this can also then enable new business models, which is my last slide. And here I just want to say that we need to, I think the smart readiness of buildings and technologies such as building automation and control system really opens up for new business model that can help us to increase the renovation rate and reduce energy in smart ways. And we really need to reduce and remove the remaining barriers to these practices such as demand response. And with that, I want to leave it back to you, Pernille.
Thank you very much, Jonathan. Thanks a lot. And thank you for bringing this new element, or talking a bit about the positive energy districts, because our next poll is actually related to it. Could we please have spent 1 minute on it? And in the meantime, I would like all the panelists to get ready to come to the panel. So let's see the last poll for today. And the question is, what should be the first action for the EU be to enable the uptake of positive energy districts? And here you have quite a few options, and I will read them out for you. The first one, develop clear definitions of positive energy districts. Second, easier and broader participation of buildings in demand flexibility. Third, removing barriers to local energy sharing and to the market. Next, improve the interoperability of data, cybersecurity, and data protection. Then require municipalities to develop long-term plans for their building stock, including uptake of positive energy districts. And the last option is require the inclusion of positive energy districts in the long-term renovation strategy or and national energy climate plans. Okay. I'm so happy to see our active audience here. It's changing so quickly. Very good. Okay. So it's now getting stable, and we're also running out of time. I would like to take some of the questions from the audience. Jonathan, apparently the winner is to develop the clear definition. I think clarity is always useful. And of course, combined with removing barriers. And the third, very preferred option is to require municipalities to develop these plans and include positive energy district aspect in them. But also the second option has quite a bit. You can see for yourself. Apparently, there are supporters of all of these suggested actions, which is great. Okay. So thank you so much, and I think we should move now to the panel discussion and the Q&A session. So all the panelists, please switch on your cameras and join me. Join me on stage. quite a few questions here. Let's just start with Jonathan, actually. What role the energy performance certificates could play to support the uptake of smart buildings?
Yeah, thank you, Bonnie. And I think really, I mean, the energy performance certificates are, they have their flaws, of course, but they're really becoming an instrument that shows the energy performance of buildings that they were declared to do in the beginning. I think, of course, you can make the link to the smart readiness indicator and so on, but I think we should use this one paper that you have on the energy performance certificates to really illustrate or show information that homeowner or buyers of buildings are interested to know. And one of them can, of course, be if the building can participate in demand response, because then they can, of course, earn some money on that in the future. But then there's, of course, also the link with the energy performance certificate databases. I mean, what is stored from the data, and they're making the link with the digital building logbook, and by doing that, also link the energy performance certificates to actual energy consumptions. I'm not saying that we need actual energy consumption as the only thing in the energy performance certificates, but we need both the measured value of what is the energy performance of buildings, but then also how much energy does it actually use. I mean, if I'm buying a building and I want to have a quite good idea of how much I will have to spend on energy in my building.
Okay, thank you, Jonathan. Thanks a lot. So there is a statement from someone from the audience saying it is not if smart technology is essential, but is the adoption of smart technology essential? That's a comment here. And I would like to ask you, Nils, you spoke about building automation. Is smartness in buildings really feasible and necessary for everyone?
I think I talked a lot about necessarily how necessary it is and how important it is to bring all the different components of the building, and mainly the technical components together, and also to make sure that during the operation phase, what is the longest time a building exists, we really aware of energy consumption and all the operational issues, also the comfort we have in the building, what is also important for the usage, as also mentioned here before. So therefore, it is a need to make sure that the building will be in a good operational mode also in the long run. Is it feasible to do that? I believe we have the technology in place now for years and also decades, but it's improved in the last years. It's more and more easier to combine different components from different suppliers for different systems. There are standards in place for doing that, new standards coming up also with all this IoT readiness or IoT capabilities of components. So therefore, I believe it's definitely feasible. For sure, you have to think about, before you are starting to combine all these things, what is the functionality or what you want to reach with that building and how the components and systems should work together. That's from my point of view, most important part. And the technical solutions are there. You can use that. You can use standards. You can do that on a one-to-one base. Standards have the advantage that it's not a one day solution, as I say that in that way, but it's then also a solution you can advance, change, or whatever during the operation of the building. So therefore, I would prefer going into standards communication and using that as a base of all the combined functionality you should have and you need to have in a smart building for ensuring low energy consumption and a good operation over time.
Thank you, Nils. Thank you. And here we have a question, I believe, for Ourania. It is in regards to the active load management that is in some way load shedding. How can we design lighting systems to work with this? And we need some real numbers for percentage of load to be reduced to make financial arguments to clients for the additional wiring and control required to make a lighting system still be functional while requiring to reduce the active load. Ourania, I'm not sure, are you able to answer this question? I mean, it is a bit in combination with this active buildings functionality.
Yeah, that was a mouthful, wasn't it, Bonnie? Thank you for that.
Absolutely, but I want to really read it out loud, yeah.
Thank you for that. I think it's a fair point. Lighting cannot just rely on someone giving it energy when energy is available. We need to have lighting on when you need it, so it has to be driven by demand. That's true. And there are studies going, I don't have the numbers off the top of my head, but whoever put that question can happily follow up by email afterwards. The email was in the slides. There are discussions going around building a model which demonstrates the financial benefits of going to lighting systems. And I think that case is already being made because there are people who move to that direction without looking for additional financial support or trying to figure out how to make it happen. The energy savings make the return on investment deliver quite soon. But I'll happily follow up by email.
Okay, thank you very much, Ourania. Thank you for this offer. So there was a question about interoperability and using different languages with smart technologies. And we have here bricks and haystack mentioned, but I think, Nils, you already sort of addressed this by mentioning standardization. I think that this is probably the way it should go in the future. And I think we have quite a bit of advance in this area, in building automation. So I will go to the next one. I believe this is just a statement. What I miss with eu.bac mission statement, while safeguarding indoor environmental quality. The main objective for buildings is not to save energy only, but to provide a good place to work while saving energy. And I think I'll take this one myself, Nils, because I think actually what is in the statement of eu.bac is completely correct. It is exactly that. So, of course, primary is to provide the indoor environment. But when you have building automation and controls, you can also save energy while doing that. Okay. perhaps it's just a matter of interpretation, but thank you for the comment. Yeah. Yes, Nils.
But maybe I can add something on that. For sure, at least building automation and controls is, and that's also what I explained. It's at least an enabler also to make sure that we have a good, I had it air quality or good air in a building, and so therefore with that, and also having all these productive environment for people in building, air quality is air or environmental quality is key for that. And building automation controls is an enabler, making sure that it is feasible, and you can have that over a long time. So therefore, it's also what eu.bac is clearly supporting, that air or indoor quality is key. Using the equipment, the building automation and controls industry is providing to that, to making sure that it's really happening.
Yeah, right. Thank you, Nils. So I will take one last question. We are on the hour now, so officially our webinar should be closing right now, but I'll take one more question because it's very interesting and we haven't touched on it. And it is, what impact does building information modeling and digital twin has on the EPBD? Anyone that would like to take this? Jonathan, perhaps you?
No, I don't. I think of course BIM and digital twins are very interesting, and I think there are many interlinkages with the digital building logbook that I mentioned. But I'm really not an expert on this concept.
All right. So if anyone else can answer that off the cuff, if not, we'll actually close this event. And if you agree,
let me give a comment on that.
Yes. Yeah.
On a very high level, because it's maybe it's a separate webinar going into that. These are not two different things, but we will find and work with that also in designing buildings. BIM is key for that. And at the same time, we want to use that also then for building up all the information we have there, to building up a digital twin of the building. What I also mentioned as part of data analytics, having all the data in the cloud, doing comparison, seeing how the building is used, if the building is the building is used in a different way, so we will see that also in energy consumption. Maybe more lighting is switched on for certain reasons, because more conferences in the evening, all this kind of stuff, and to having that, watching that and seeing and having also the intelligence behind that something is going wrong. So therefore, at least a digital twin is key to have the full picture of the usage of the building, and with that you are able to react if something is going out of the expected energy energy footprint. So
yes, Nils, thank you. I think we really definitely. There is a lot of convergence in using digital twin and building automation, that's and other smart technologies in building. So this is really this is happening. So, but I really have to close now, and all that I want to say is first, while end-use efficiency has always had system benefits, digitalization allows for these benefits to be measured and valued more quickly and more accurately. Digitalization is modernizing energy efficiency, and it can unlock greater efficiency if barriers are removed. So we look forward to seeing Europe's global climate leadership translated in sustainable, green and digital measures in the upcoming EPBD revision. The revision will make it the keystone legislation for the European Green Deal that will either support or undermine the entire European green transition. We all have the obligation and the opportunity to make a difference. So with this message, I'm closing this event, and thank you so much to everyone that joined us today. Thank you to all the panelists. Thank you so much. Thank you to all viewers, and stay safe, stay well, and enjoy the rest of your day. Thanks a lot. Bye.
Thank you. Bye.
Thank you very much as well. Bye.